So, in the last class, we have discussed in detail the different repetitive structures. That is the loops, for loop, while loop, do while loop. Then we have seen how to execute single loop and how the dry run of a single loop will execute. Then the nested loop, and under the nested loop, we have seen different patterns, how to represent patterns. Now, today, and if you remember that I have also told that repetitive structure can be represented either using loop or using function, or you can say recursive function. I hope you remember recursive function. Okay. Now, but one thing that is very important in case of recursive function, that is the problem should have some the problem which we are going to represent should have some recursive definition. That is very important in case of recursive function. Okay. And yes, obviously we can use loops for while or do while, anything. But there are some cases or some places where, although it looks like some pattern or looks like some repetitive thing are happening, but we have to go for functions. So let us take one example. Suppose you have to print a pattern like this. You have to print a pattern like this. Okay? You have to print a pattern like this. Suppose in your problem, you have to print a pattern like this. Suppose this is your pattern that you have to print. Now see, in this pattern, it is very difficult to represent them with a nested loop structure. It is very difficult. Okay? So the solution is you have to go for single loop for single pattern. Single loop for single pattern. So for this pattern, this start print, see there is no pattern relation. First line, you are printing star 6 times. The second line, you are printing @ 4 times. In the third line, you are printing $5 times. In the next line, you are printing #7 times. In the next line, again, you are printing @ 2 times. In the next line, you are printing the star 3 times. So let's go. So if you see carefully, there is no relation with row. With the increase of row, there is no relation with the value that we are printing in the column. That's why we are not able to use any nested loop. So what is the solution? The solution is single loop. Now, if I create single loop for single pattern, then how many loops I have to create? First, for loop, which will run 6 times for the star. Next, another for loop, which will run 4 times for the @. Next for loop, I have to repeat 5 times for dollar symbol. Then for hash, I have to run it 7 times for hash. Then, so I have to run the for loop, single for loops. I have to run it 6 times because there are 6 different patterns, 3, 4, 5, 6, 6 different patterns. So I have to create 6 different for loops. Now, one better solution for this type of pattern where there is no relation along the row. There is no relation. Remember this, no relation along the row. Then it is very difficult to represent them using a nested loop structure. The better solution, or you can say the ultimate or exact solution, is use function. So there comes the use of function. Better solution is function. Why we are using function? See, again, function is again used to perform repetitive things. If you are repeating something and there is no relation, repetitive structure with no interrelation, then the better solution is go for function. So we can perform the repetitive structure of C language either using loop or using function. When we will go for loop, if there is a relation or interrelation between the repetitive structures, then we will go for loops. If there is no interrelation, they are, you can say, they are independent. There is no dependency between 2 different repetitive structures, then better go for function. Suppose you have to use the sum of 2 numbers, say 7 times in your program. You need sum of 2 numbers 7 times in your program. Then better create a function for sum of 2 numbers. Why? Because there is no relation between the sum of 2 different numbers. They are independent. They're not dependent. So that's why the better solution is function. So when we will go for function, obviously there is some repetition, something we are going to repeat again and again. Then we can go for function. But when we will exactly go for function, if there is a repetition and the repetitive structure don't have any interrelation, then go for function. And if you remember, in our second or third class, we have discussed about function, how to write a function. I hope you remember that function has 2 types. One is user-defined function and another is library function or predefined function, or you can say C functions, okay, which are already defined, in the header files. So that's why for this type of function, what we have to do, we have to just call the function, just you have to perform function calling. But when you are defining your own function, user-defined function, then first you have to define it, then you have to call it. So for user-defined function, the 2 parts, definition as well as function calling, must be there. And there is one optional part, if you remember, that is function prototype. Okay. So for this type of problem, for this solution, for this problem, what is the solution? The solution is pretty simple. Since the pattern type and number of times both are changing, so from the repetitive structure, the next thing that you have to understand, from the repetitive structure, one thing that you have to understand, whether there is interrelation or not. This is the first thing that you have to take care. Then the next thing, if there is no interrelation, then what are the variables? What are the variables? What are the variables? Okay, those variables finally becomes the arguments of the functions. Just remember this. Which things are variables? Suppose you have to perform sum of 2 numbers. Those 2 numbers are varying. That's why these 2 numbers are variables. So those 2 numbers becomes the arguments of the function. If you remember the example of function, the example of function is, suppose I have to submit the electricity bill. Then what I will do, I will pass the, so I will call someone else to submit the electricity bill. And what are the arguments? The arguments are the electricity bill and the money that he has to submit. Okay. After submission of the electricity bill, the person will return me one receipt that he has successfully submitted. Okay. So those are the things that you have to remember when you are going to represent any problem with respect to function. Okay. Now the solution for this function, since this function which will only print. Now, what is the purpose of this function? To solve this problem, the purpose of the function is only print. Okay. Now, what are the arguments? Arguments are, since the two things are variable here. What are those? One is the character type. Okay. See, sometimes it is star, sometimes at the rate. So the character type and how many times. So these are the two arguments. Since it has only to perform the printing, so the function will return nothing. So the definition of the function will be like this: void, the return type. Then, so again a recapitulation. So first you have to represent the return type. Then you have to write the function name. Okay. Then this function symbol, parenthesis. Within this parenthesis, you have to write the data type and argument name 1, comma data type, then argument name 2, dot, dot, dot. Okay, and this, then within this curly braces, you have to write the definition. So this is the syntax of function, user defined function. Okay, so for this case, what is the return type? Since the function is returning nothing, so it is void. Then the name. So suppose print pattern. So this is the name of the function. Remember, the function name should be a user defined name, not same as C or library function. Okay, that is very important. And what are the arguments? The first thing, character, which pattern we are going to print. So it is a character type. So the first argument is character, and the next argument is how many times. So next argument is number of times, integer n. So these are the two characters. Then inside this, what I have to do, I have to declare one I for counter, then the for loop for I equal to 0, I less than number of times n, I plus plus, then the printf for this particular character, that's why %c, ch, okay. Then after that, one, after the completion of the for loop, one new line. So this is the function that I have to define. Then how to call the function? So this is my main function, from where I will call the function again and again. So how I will call the function? The first pattern, it is a star and it will print 6 times. So I will call the function in this way: print pattern, then the character with single quote, and then number of times. These two are the arguments. Next, function calling print pattern. The next character is at the rate, and it is 4 times. So in this way, you have to call the function. Okay. So I hope the thing is clear that when I will go for function, if there is a repetitive thing happening inside your problem or inside your program, and there is no interrelation between the repetitive structures, then go for function. Okay, see here we are only using one for loop, but if I write this function in a this program in a normal function, then I have to write 6 for loops with different iteration. Here I have created only one for loop with variable iteration, and those variables are nothing but the arguments. So I hope the use of function is now clear. When I will go for function, if the same thing is happening again and again, we need the same thing again and again, and there is no interrelation between those things, then we will go for function. Okay, and what is the advantage of this function? See, the advantage of this function is we have to write it only once. We have to write it only once. Okay, if you something again and again, if there is any mistake in any of the for loop, my output will be a wrong one. But since I have created only one function, it means I have written the whole thing only once. So whatever error will come, will come. We have to check only this function. No need to check all the for loops again and again. So this is one very interesting advantage of function. That's why we generally go for function if there is some repetitive structure, or even if there is some huge thing that we have to perform and there is a chance that that thing may be used again and again, then better go for function. Okay. Now I will show you one recursive function that is factorial. I will show you one recursive function in factorial. Okay, so factorial having two different definitions. In factorial having two different definitions. One is simple. One is simple multiplication of 1 into 2 into 3 into dot 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 up to n. And another definition, which is called the recursive definition, is like this: factorial of n is equal to n into n minus 1 factorial. So this is a iterative definition. This is called iterative definition, and this is called recursive definition. Okay, so why it is called recursive definition? The reason is, to know the function of factorial n, we have to call another factorial function. It means the factorial function itself calling the factorial function. That's why it is called recursive. When a function call itself, it is called recursive call. So same thing is happening here. But in this case, the definition is simple. We are repetitive something. We are multiplying. This multiplication is repeated again and again. So that this type of definition is called iterative. And since there is one relation, see, first it is 1, then it is 2, then it is 3, so it is increasing by 1. So there is some relation between this repetitive structure. So we will go for, definitely we will go for loops for this case. Okay. Now the simple factorial definition will be like this: for I equal to 1, because it starts from 1, then it will go up to n, so I less than equal to n, then with each iteration it is increasing by 1, so I equal to I plus plus. Okay. Then since it is a multiplication, so the first one will be multiplied, this one will be multiplied one variable, and that variable must be initialized with 1. So remember, if we are performing multiplication repetitively, then initialized with 1. And if we are performing addition repetitively, then initialize the variable with 0. Okay, so this is multiplication constant and this is addition constant. Remember these two things. Okay, so we have to declare one variable f with initialized f or anything with, which will be initialized with 1, because we are performing repetitive multiplication, and the rule is the multiplication constant is 1. So what is happening? This 1 is multiplied with f. Okay, then the result is again stored in one variable, and then 2 will be multiplied with this. So that's why what we will do, we will store the value in f itself. So we will write it like this: f equal to f into, since I is the variable which is varying 1 to n, so the definition will be like this. So this is the repetitive definition of our factorial function. Okay. Now the iterative definition. So sorry. So this is the iterative definition. Okay. Now we are going to the recursive definition. So the recursive definition is like this, that if we want to calculate the factorial of n, then we need factorial of n minus 1. Okay. But remember one thing, recursive function has a tendency to become infinite. So that this is one tendency for recursive function. Why? Let's see that suppose I have to calculate the factorial of 3. Then to know the factorial of 3, the definition, according to definition, it will call factorial of 2. So what is the definition of factorial of 2? It is 2 into factorial of 1. What is the definition of factorial 1? It is 1 into 0. Then what is the factorial of 0? It is 0 into minus 1 factorial. So in this way, it will move on and on. So it becomes infinite. So we have to stop it either after this or after this. Okay. So it means in case of recursive function, one terminating condition is very important. See, the terminating condition here is this one. Since we are calling the function again and again, so we have to stop it after some iteration. That is very important in case of recursive function. Otherwise, it becomes infinite. So you have to understand what is the terminating condition. So the terminating condition is this, that when the factorial of 1 is required, the value is 1. Or when the factorial of 0 is required, the value is 1. That is the terminating condition where you have to stop. Okay. So from the definition, it will look like this. Factorial of n means n into factorial of n minus 1. So this is the actual definition. So inside the factorial definition, you have to call the factorial again. So how to define it? So since this is a factorial function, it will return the factorial value. So the factorial value obviously in integer form. So it will return some integer value. Int fact. What is the argument? The argument is for which variable you have to calculate the factorial. Okay. First I am writing the iterative one. I, f, then for I equal to 1, I less than equal to n, I plus plus, f equal to f into I, then return f. So this is the iterative definition. Okay, this is a simple iterative definition of the factorial function. Now the recursive definition. Int fact int n, same. Then inside the definition, instead of loop, we will use, I have already told you that loops can be represented or replaced by recursive function, but the condition is there must be some recursive definition. Okay, so you can easily convert it. So the condition, the first you have to give, this is the must, very important. First you have to give the terminating condition. What is the terminating condition? If n is equal to 1, then what is the factorial value? The factorial value is 1, so it will return 1. This is the terminating condition. This is the very important thing. And then if this is not happening, then what is the definition? According to definition, factorial of n is equal to n into factorial of n minus 1. So else you have to return, what you have to return? You have to return n into factorial of n minus 1. See, this is the definition, so I am writing the definition itself. So this is your recursive factorial function. Okay. Now I hope it is clear. Now, how this will be executed, we have dried on this part. Okay, now we will drive on this recursive function. See, suppose the value of n is 4. Okay, so this int n will be, so how to call the function? The function will be called like this, fact of 4, and it, since it is returning something, it will store the value in a third variable. I hope you can remember that when a function returns something, that must be stored in a variable. So I have stored the value, so this is the function calling, and obviously r must be same as the return type. What is the return type? Integer. Since r is storing the return value, so r also must be an integer. Now, so this is the function calling. Okay, so after, so this 4 will come into this position. So this int, this will convert it to int n equal to 4. So this n is now initialized with 4. So if you remember, this n is inside this function a temporary variable. Suppose the address is alpha, and this inside this is suppose main function, and inside this main there are other variables, suppose r and other variables. Okay, so this n is now initialized with 4. Now, first thing that it will check whether n is equal to 1. Since it is not equal to 1, it will move into else part, where it will call again this one. Okay, so n into, so for this 4 into again a factorial, means it will again move into this part, factorial, and now it is n minus 1. So this statement will be now again initialized to int n equal to 3. Again it will check, is it 1? No. So again it will move into this part. So for factorial, for this it will call 3 into again a factorial definition. So again it will move to the factorial function. Since it is a definition, it will move into the definition. So now this time this will be initialized to int n equal to 2, because n minus 1. Again it will check, not satisfying, so it will again move. So this factorial again call 2 into, so this part 2 into again a factorial. So again it will call the factorial function. So this time it will be initialized like this, int n equal to 1. Now this is matched. This thing is satisfying. So it will return value 1. So this factorial will return, this factorial will return 1. So now this multiplication will be done. And after this multiplication, it will be returned to here. Now this multiplication will be done. This will be returned to there. And finally, this multiplication will be done, and the final result 24 will be returned. So your factorial function is called like this, and when it is executing like this. So this is called last in first out operation. See, the last call is multiplied first. This is the last factorial call. This will be multiplied first, then the next, then the next. So that's why it is called last in first out. And this type of data structure is called stack data structure. So whenever you are representing any function, this type of stack data structure is very important. You will learn about this in your data structure class. Just an idea. Okay, so in this way, this factorial function will be executed. Okay, now the question is, if I ask which one is faster among these two, which one is faster, which will execute first time, this iterative one or the recursive one? The answer is the iterative one is faster. Why? Because in case of recursive function, again and again you are calling a function and you have to get back to that function. It means, suppose I have to submit the electricity bill, so I will again and again call the person by phone, please come and collect the electricity bill and money. please submit the electricity bill. Every time I have to call that person and he has to return me the value. So it will take some time. But if I perform iterative one, it will be, it means the performance is done by myself. I am going to submit the bill, I am submitting, I am doing everything. I'm not calling someone else. I'm not wasting my time by calling a person to submit or to do the work in favor of me. So it means iterative one is always faster. This one is always faster than the recursive one. Okay. Now the next thing, in case of recursive one, we require more memory. Why we require more memory? Because every time I have to declare a new n variable, I have to store the previous value in a temporary variables. I have to store the previous value. But here I have to declare only two variables and that is enough. But in case of recursive function, we have to call it, we have to allocate the memory again and again. So it is with respect to time and space. Iterative one is better. Iterative one is better than the recursive with respect to time and space. But still, we use recursive function. Because it is easy to write. See how many things you have written here and how many things you have written here. It is easy to write. Is it easy to understand? That's why to minimize the code complexity, in sometimes we use recursive function. In your data structure class, you will learn that there is one problem called Tower of Hanoi, which is very difficult to represent using iterative way. But if you represent the Tower of Hanoi in a recursive way, it will take only 4 lines. But if you represent the Tower of Hanoi in iterative way, it will take more than 50 lines. So it is very easy to understand, very easy to represent. That's why we sometimes use the recursive function. But the recursive function is always extensible with respect to time and space both. Okay. So next we will try to understand our last day's one interesting problem, that is called Pascal's triangle. I hope you remember the Pascal's triangle. So this is 3, 3, 1, then 1, 4, 6, 4, 1, then 1, 5, 10, 10, 5, 1. So this is Pascal's triangle, and I hope you remember that the logic is we are using NCR concept. Now what is NCR? We know NCR means factorial of n divided by factorial of n minus r and into factorial of r. So this is the definition. So it is like this. You have to call factorial of n, then you have to divide it with factorial of n minus r into factorial of r. So you can understand that you have to call the factorial function 3 times. Okay, and there is no relation between the factorial functions. So it is obviously very useful to call a function for this factorial. So we have already defined the factorial function. So we will use those definition and see when we are checking the patterns having some relation. The pattern having some relation. There is a relation along the row. So we will use the nested for loop here. Okay, so this is one classical example where we need function as well as nested for loop. So just the the skeleton of the function. So so it is like this. The first line is 0 C 0. The next line it is 1 C 0 1 C 1. Next line 2 C 0 2 C 1 2 C 2. So the pattern is clear. So this is representing the row value. Okay, see row 1, row 0, row 2. So this is representing the row value, and this one representing, see, 0 column, 1 column, 2 columns. So this is representing the column. So it is like this. If I represent I for row and J for column, then the NCR will be look like I, C, J. Okay. Now only 1 minute, so I hope you will rejoin. So I'm just writing it in fast. So for I equal to so it is initialized with 0, so 0. So how many rows? 1 2 3 4 5 6. So I less than 6, I plus plus. Okay, then inside this I have to define another for loop for the column. So J